We're moving on in our research methods, and we're now looking at the area of data gathering. It's an important part of research methods. It's a little bit more technical in some aspects, this, for the moment. We'll have a look at that. But first, let me tell you a story. In, I think it was the 1960s, there was a researcher called Stanley Milgram who did a famous experiment. I've talked about experiments already. I've told you about Galileo and people like that. This is a more recent experiment, one that was done by a psychologist, and he wanted to find out information about not gravity, but about human beings and about how they act under certain circumstances. And his experiment was an interesting one. He laid out a kind of lab situation here, and he hired or got in two lots of students. The first student sat on this side of the table, and the other student sat on this side of the table. And this student here was given the role of being a questioner, and that student was given the role of being the answerer, answering questions, and this student was going to test that student. Okay? And the way this was set up was it was a test under stress. And the idea was simple. He would wire up the student to an electrical wires to each wrist, like that, and wire it in to a device which would give electric shocks to that student. This student here was to sit and ask questions, general knowledge questions, questions to test their knowledge. And every time they got an answer right, ding, a bell went. Well done. Every time they got an answer wrong, the student who asked the question pressed this button. When they pressed that button, the person at the other end got a shock. Ah! Like that. Okay. And in order to test the effectiveness of this, they wanted to see how well people answer questions under test. In order to do that, they then told the person here not only to press the button, but every time they get one wrong, turn the dial up one more notch, so the shock becomes stronger. Testers one. Person sit down, ask the question, person gets it wrong, presses the button, ah! Turn the notch up a little bit, ask another question. Person gets it wrong, person over here presses the button, ah! Even worse. So it goes on through the questions. As this dial is going up, the shocks are getting worse and worse. As the shocks are getting worse and worse, the dial is going up. As they get more questions wrong, sweat is breaking out on them. And as the dial goes up, it's entering into the red area, which says danger. They look up at the guy and say, shall I continue doing it? Yeah, the experiment's going fine. The experiment's going good. Keep going. They turn the notch up, press the button again. The dial is now going up into the black area, which says danger of death, critical. Should I press the button? Yeah, keep going, it's okay. They press the button. And the guy gets a shock and collapses. That was the experiment. That was Stanley Milgram's infamous experiment. It was infamous because, in reality, what he didn't tell these two people here, or one of them anyway, was that he wasn't testing stress under answering questions at all. He was testing something completely different. What was he testing? He was testing whether someone here, this was a real student, this was an actor who wasn't really getting any shocks at all, but just pretending to. He was testing this student to see if they would follow orders, no matter how deadly those orders might be. If they were told by a man in a white coat, yeah, keep going, keep giving them shocks, would they carry out the orders? And by a method of observation, he discovered some very interesting facts about human nature. What he discovered was this: he discovered that nearly every single person he tested carried on giving those shocks under orders, even at the point where it might mean the death of the subject. If they were told by a figure in authority to keep on doing it, most people did. Astonishing conclusion, you might think, but that was an astonishing experiment. It became an infamous experiment because, for many reasons, the experiment was criticised because they didn't tell people what was really going on, they deceived a lot of people, and because the results themselves, I think, were so controversial. But nevertheless, this is the way scientific experiments are done. This is the way that data is gathered. This is the way that information is obtained, one of the methods. And this method is the scientific method. This is by experiment. This is by testing things. This is by trying things out. And sometimes the lab setup that you have can be very controversial, but it can be very effective in producing new information and primary research. Now, we're involved in research methods. And if you are going to be involved in doing research, somewhere along the line, you will be gathering in data. You'll be gaining information. You may not have such a controversial experiment as Stanley Milgram had in finding your data, but you'll be getting data from a wide range of sources and areas. And what I want to talk to you today about is how you can gather that data in, and the kind of rules that you need to follow in order to ensure that your data is valid and effective and useful. You know, it's often joked that as computing and IT students, we are very, very interested in data, in getting data. Data is what IT and computing is all about. But what we often fail to remember is that data is meant to provide us or lead us towards information. And information is meant to produce knowledge. And knowledge is meant to produce understanding. And understanding is meant to eventually result in wisdom. And very often we're just content to stick with the data and we forget the rest, which is a great tragedy, because it's the understanding and the knowledge and the wisdom which are the important bits about it. But I'm going to talk to you now about making sure that your data and your information is good, and how you can use various tools and techniques to gather that information in. So that's our subject for today. The first step then is I want to look at the methods that you might use for gathering in your data, or where you're going to get data from. Now, you will have a range of different projects to do. You've got all kinds of different things you've got in mind. Some of you are fairly clear about your project now. Some of you may change your mind later on, I don't know. You're welcome to do so when you do the real project. But each of you has got some kind of area in mind, quite different from other people. That's fine, that's as it should be. But you'll need to have some way of gathering in data. Of that, I'm reasonably sure. And we're going to look at the way in which the methods that you might use to do that. There are a range of them. These are by no means exclusive, all of them here. But this is a good number of them. And these are the standard ones, if you like. The main ways of gathering in data I've got is observation, in the same way that Stanley Milgram did his experiment. I've got simulation. We've got interviews. We've got focus groups, which is a kind of interview structure, and structured questionnaires. Out of the kind of projects which I've seen in the past here, The surprising result is that most master's students end up trying to get some primary data, often using these last three, but mostly the questionnaire, which is surprising, but very often you want to do some research, and questionnaires tend to figure very strongly in most people's practical project working. So I'm going to concentrate quite heavily on looking at questionnaires, but I'm going to mention something about all these other things as well. Okay? And I will try and set this up in such a way that I believe it will be most useful to you in practice. Okay. Let me say something about each of these things in turn. The first one, observation. I have already described to you one experiment based upon observation. The observation was very instructive. But observation is probably the first and primary method of gathering in data. It ties in very, very strongly with the scientific method that we looked at some weeks ago. Remember, the method that we use must be a scientific method, because it's the scientific method which guarantees the authenticity and the reliability of the information that we gather. The whole purpose of the scientific method is that we don't end up with information which is untestable and which is subjective or made up, or something which is just insubstantial. The very importance of what you're doing as master students is that the information you're dealing with has to be authoritative, it has to be reliable, it has to be something which other people can depend upon as being true. If it's not, it's worthless. Okay? It's worthless. So we need to make sure that the steps we take are ones which are going to guarantee the reliability of our information. The scientific process, we said already, is a straightforward one. It's very simple, really, but it's one we must follow very carefully. You observe something, and then you ask your questions about it. When you've asked your questions about it, you can make a hypothesis. You can then, when you make your hypothesis, you make some predictions about how the consequences of your hypothesis will work, and then you go away and you test your predictions by an observational experiment. So we mentioned Galileo. He observed something. Things fall down to the ground. He made a hypothesis. Heavy things and light things fall down at exactly the same time, the same speed. He made a prediction about that. Well, if I take a wooden cannonball, if I take a heavy lead one, if I drop them and measure it, they should hit the ground at exactly the same time. I will go and test my prediction, and I will observe it experimentally. I will go up to the Leaning Tower of Pisa. I will take my two cannonballs, one made of wood and one made of lead. I will drop them over the edge. I'll get someone at the bottom to check and observe when they hit the ground. And that is an experiment that can be repeated by anybody anywhere. It doesn't have to be in Italy, in Pisa. It could be in London. It could be in America. It could be anywhere. And they all find the same thing. And you trade your conclusions. And that's how you work that kind of way. To give you another example, that there is essentially a hypothesis which you might use, and hypothesis is at the basis of this kind of testing. You make a hypothesis, which is an educated guess as to how things work, and then you go ahead and test it and see if it really is like that. In the old days, people used to just use their hypothesis as the truth. That's how it is. But it's not like that. You have to go and test it to make sure it really is the truth. So supposing you were a zoological experimenter and you experimented with cats. Supposing you formed the hypothesis. Here's your hypothesis. That cats of the same colour play with each other, and they don't play with other cats of different stripes and colours. Supposing that's the kind of thing. So that's your hypothesis. What you do is you go and you take a bunch of cats, you put them in a room, you put up some cameras, You observe them, and then you record all that, you come back, and then you analyse all the data, and you say, I have found out that it doesn't matter what the type of cat you've got there, what colour fur they've got, all that kind of thing, they all play together. They're all very egalitarian, which is a good thing. So after about a week, and you find that your hypothesis is therefore proved or disproved by your experiment. And that is how many discoveries have been made. And most of the scientific discoveries in this world are all made by that same simple process. You make a hypothesis and you check it. If it doesn't work out, you scrap it. You start again with a different hypothesis. Observation. The key methods. Now, it may be that you are setting up an experiment of some kind in a lab, and you may well be doing something of this nature. It's unlikely, I've found, in practice, because often these kinds of experiments are not usually what master students do, but it might be the kind of thing that you have in mind. In which case, you will need to follow a strict scientific method, careful observation, and documentation of that. And that's the first way which you'll gather your information. Another method is what I've called here simulation. This is possibly much more likely the kind of thing that you might be doing. Simulation I've got here is essentially creating a model of the real thing. You're not going to work on the real thing because the real thing is too big, or the real thing is too complicated, or the real thing is too hard to control or to look at. So what instead you do is you create a model. You use a model to predict how a real system will operate. Here's one I picked off the internet. Here is a 48-hour computer simulation of Typhoon Marwa using the weather research and forecasting model. So they've got a computer model which models wind patterns, and they put in, this is where it is at the moment, what's it going to be like in 48 hours' time, and they simulate it. And through that simulation, they can make predictions. The predictions is going to spread out this way, it's going to move that way, it's going to do this, and the other. Of course, you can test your predictions later on. You test them because you actually see 48 hours, has the typhoon moved in this particular direction, or has it not? And therefore, you can check your model, how good your model is. Once you refine your model and improve your model, it can become a more accurate tool for further predictions. And you can find and gather information this kind of way. People use models for all kinds of things. I've got weather forecasting, I've got flight simulators to train pilots, and they're finding out information about how good a pilot might be. So instead of putting them in an airplane, flying them off, put them in the simulator and find out where their errors might be. You can design, you can put buildings under stress in terms of earthquakes zones, for example, see if the thing will fall down on a model. Better that than do the real thing. See if it falls down. Robot simulations, traffic simulations happen all the time. And it may well be that your project might involve a simulation. I don't know if any of you are doing networking, but for example, there are networking simulation packages like OpNet, and I know a number of students may use OpNet in order to simulate network load, and then they can test it in various areas, and that can be part of your project, gathering information from the simulation. So that's one other area you might gather stuff from. More often than not, what I find is that you're gathering information from people. These are scientific from a certain point of view, statistically from a point of view. But there's a huge amount of information to be gathered from human beings and how they use various things, how they interact with things. We all use mobile phones or we use laptops. There's a huge amount of work goes on in terms of the usability of certain stuff. There's all kinds of things. And one of the ways in which we often gain information is by interviewing people. I mean, sitting down with them face to face and talking to them. Now, you can't do that in an unstructured kind of way. Because if you do, you might end up asking a whole range of people. Say, I need to talk about 20 people or 30 people. I want to talk to them. But if I ask them different questions, I come up with a range of different answers. So I really need to standardize my process so that I'm going to ask every question, every person the same questions, and the same set of questions, and in the same order, and in the same kind of way. So hence the word structured here. Interviews on their own can be very, very general, very open-ended, and they may provide you with more kind of qualitative information which may not be that helpful to you. But a structured interview is much more important, because a structured interview will allow you to standardize the information you get back. And that's what I've got here, presented with exactly the same questions in exactly the same order. And so if you're going to use an interview technique to talk to people, you have to be very, very careful that you use a structured process for this. It's not good enough just to have a set of questions. You have to stick rigidly to them so that you give everyone the same opportunities to give the same kinds of answers to the same kinds of questions. Otherwise, you undo your process and it becomes non-repeatable. So that structuredness ensures that the answers can be aggregated reliably, put together reliably, because they've all gone through the same process, and therefore they can be combined, because they've been asked exactly the same question, in the same way, in the right order. That's important. Otherwise you can't make comparisons with any confidence. So when you're doing interviews, I want you to realise that there is a way in which they have to be standardised and structured. We'll talk about that in a bit more detail maybe later. I don't know if you've come across the idea of focus groups. It's another way of structuring your information. You can get groups of people together and you can get them to discuss a particular question. I've been a member of a number of focus groups now, and they all seem to sit around the table. You end up with 7, 8, 9, 10 people, and someone chairs it and someone takes minutes, and then what happens is a set of questions has gone through, and everyone debates and discusses and shares their information about that. And there's often an interplay of exchange of different views, which can persuade people differently, but a consensus then often arises usually, and that consensus is drawn down, and then that is used as part of the data that you're gathering. It's effective for particular kinds of groups, particularly young respondents, people who use English as a second language, because you're able to guide them more, and people with low literacy skills are quite usefully involved in that, because it's more easy for them to be guided by that kind of thing. Respondents can answer and build on each other's responses, improving the data. That's the advantage of having them all together. You don't do it one by one after the other. You do them all in a group, because then this person says that and this person says something else. And says, have you thought of that? And so the group gel. Disadvantages: it may not fully represent the opinion of the larger target, and the facilitator must be well trained in case any arguments occur. And sometimes they can, or sometimes some difficulties can. But this is a useful method, and it's a very, very common method used by political parties and by companies who want to find out whether their product is going to be really useful or not. So you get your group together and you observe them carefully. You make sure that you've got here a picture of people behind a glass screen looking at the focus group. They're recording things here out of sight of the focus group. There's a facilitator over there, and everything's being recorded carefully. Things can be analysed later. But probably the most significant thing, the one which most of you here will use, in my guess, my best guess, is the questionnaire. And there are two kinds of questions on the questionnaire. In fact, there's two kinds of questionnaires, which I have not mentioned here. But the two kinds of questionnaires are self-administered questionnaires or interviewer-administered questionnaires. And both need to be looked at with some care. if you ever go out onto the street and someone's doing some market research, they've got a clipboard, and they say, "Excuse me, sir, do you mind answering some questions? Madam, will you give me this information here?" And you'll go through it, and they'll ask you set questions, and they do it all for you, and that's the interviewer at the centre of it. Wasted. But then with email, you can send out 1,000 emails without any additional cost. You can bear that in mind. You can be accused of spam, so there's that problem too. Once you've decided how you're going to do your question, you then need to ask yourself the question, what kind of questions can I ask? And there are two basic kinds of question. There's what's called the closed-ended question, and correspondingly on the next slide, there is the open-ended question. The closed-ended question are of many different kinds. You've got what's called the dichotomous question, which has got two values to it: yes or no, good or bad, right or wrong, satisfied or unsatisfied. And you can ask questions like that. They can tick a box with those. Very simple and straightforward. The slightly next one up is the multiple choice question, where you ask them a question and they give us 4 choices for them to choose. But they can't choose anything other than those 4 choices, or 5 choices, whatever it is we give them. So they're closed down. There's no range or possibility of them answering anything other than what you give them to answer to the box. And there's often what's called the Likert scale, the scaled questions, which are making use of rating scales. What do you think of my new car? I think it's good, brilliant, rubbish, not so good, that kind of range of things. It's a bit like this here, you probably can't see it. Strongly satisfied, satisfied, neutral, unsatisfied, and strongly unsatisfied or dissatisfied. That's called a Likert scale, because Likert, I don't know his first name, was the first guy to use it apparently, so they named it after him. It's a scale like that. It can have, this has got 5 elements to it, 1, 2, 3, 4, 5. And it can have any number from 2, 3, well, not 2 really, 2 is dichotomous, 3, 4, 5, 6, 7, 8, 9, many in the ranges you would like. But usually it has about 5. And the only thing to bear in mind is, do you want an even number or do you want an odd number? Because if you have an odd number, then there's a neutral position on the Likert scale. And if you have an even number, there is not a neutral position. And therefore you're not allowed to take a neutral position. So if you're forcing people to take one view or the other, you use an even number on a scale. But don't forget, that will bias your data against those people who may want it to be central. And you have to have good reasons then for whether you choose an odd number or an even number on your scale. You don't pick it at random. You have to have a clear understanding of why you've chosen it. And matrix questions. This is a kind of box-type question where you put them all down like that. They're very useful for things like SurveyMonkey, things of that nature. I don't know if you've seen SurveyMonkey, a web-based thing. All those questions can be put on there very easily. The other kind of question this is the open-ended question, and it's far more difficult to deal with in gathering data this way. These are often completely unstructured questions. That's usually the kind of thing. You openly ask your opinion of something. What do you think of the government's recent budget? You can get any kind of answer from that, including rude ones. And whether you put all those down in your data, it's up to you. But the point is that you're not sure, you're not confining people, saying you've only got 3 responses or 5 responses. They can say anything they want to. And therefore you have another problem. With open-ended questions, how do you structure this data in order to make some sense of it? For many reasons, people therefore avoid open-ended questions. But they're very important for some areas where you can't really deal without them because you want people's opinions on things and you don't know what those opinions might be. So you have to decide, if you're going to do a questionnaire, whether you want closed questions or open questions. And that will determine the kind of information you're after and the kind of research that you're doing. Slow me down a bit.
The source of data you haven't mentioned is non-human interaction data, computer to computer. I think probably most people here will be using that sort of data.
Tell me about that. What do you mean by it?
Well, you might want to mine Twitter, for example, find out the number of tweets that contain the word Clarkson. You might want to find out what time people arrive at work, looking at GPS data. You might want to find out which web pages people go on. But basically, you will not be getting the data from a person. You'll be getting the data about a person from a computer.
Kind of metadata.
Still observations.
An observation. It would be classified, I think, in that kind of way. Not an experimental observation, but nevertheless, it's a kind of
Measurement.
it's a measurement of stuff which is already out there.
Automated.
And it's gathering that data. And in many ways, the real question here is, how do you preserve the integrity of that data and not show any personal bias in what you're collecting? I think that's where it may come. For example, if you've got Twitter stuff, you can't collect everything, and therefore you have to collect some kind of sample of it. And how do you choose your sample? Yeah. Any other questions at this point?
What if your study is as such that getting the data is actually difficult?
If getting the data is difficult, do you have something in mind?
But say the project ad, it's not easy to get data out of people regarding patients. They don't volunteer that sort of information.
Yeah. If you are, there are a number of techniques you can use for that. The most obvious one, of course, is seeking to guarantee anonymity. So that will come into play. But there are other techniques too, and particularly the one where you are not actually telling them what it is you're after, but asking questions in an indirect kind of way, for which you draw inferences, and that can be useful. But you have to be so careful about those kind of things because you have to be sure that you are in fact collecting data on what you think you're collecting when it's not quite direct. If that makes sense to you. Any other questions on gathering data from these kind of sources?
You want to talk about the size of the sample?
I will come on to sample size in a minute. I've got that already lined up. I wanted to talk, this is a natural kind of break point here. I want to talk next about questionnaires in more detail, simply because although Mark says that a lot of your data might be gathered from stuff which is out there databases, it is surprisingly evident from past projects that I find more than half of students are using some sort of questionnaire somewhere along the line for whatever reason. Have you got any idea yourselves at the moment how many of you would use questionnaires? Can you just show of hands here? Quite a few of you. Okay. Some of you will not be using it. How many are definitely sure you will not be using questionnaires? Okay, quite a few of you not. Okay. It's about half and half. And some of you are not too sure at this present time. So those of you who are not going to be using questionnaires, can I ask you to bear with me for the next 20 minutes or so, because I'm going to go through some of the issues which will help other people.
Can you rely on other people?
You have to in many ways, but you can also question it and test it. Depends on whether you wish to challenge it or not, whether you wish to build upon it. So was there a question over here? No, I missed. No, just. I'm wondering whether should I do this bit on questionnaires first, and then we take a break after that, and then we go on to looking at sampling, Or do you want to take a break right now? And then we go on to questionnaires and what's happening as well again. What do you prefer? Who wants to break now?
Right.
Who says stay and tough it out? Nobody. You'll find what I've found is that many research projects actually involve gathering information from human beings, and questionnaires tend to be one of the best ways or the easiest ways of doing that. And some of you are already probably planning that to do. But a badly designed questionnaire can just invalidate your results totally. So we need to make sure that there are certain rules. There are some good books on designing questions. The whole idea of designing questions is a real art, and I can only just skim the surface and give you some common pointers, really, almost just common sense pointers in many ways. But let's have a look, and I'll try and skip through these fairly quickly because I know that some of you, well, you'd all find it useful, I'm sure, to some extent. But when you're designing a questionnaire, it is not as simple as you think it is. For every good questionnaire that I have seen 10 bad ones. It is really appalling the way in which people make blatantly obvious errors, which when you stand back and think, what is the point of that? No, that is just badly done. And 10 to 1, I think, is probably a good ratio in terms of what I tend to see, because really questionnaires are an art in designing them properly and making them work correctly and getting the data that you really want. You really do need to know what your research goals are. You really need to know exactly what you're after, and you really need to know how to get hold of that information that's in there and focus in on that. And then you need to be able to know how you're going to analyze the questions. A countless number of questionnaires I've seen where people ask questions, obtain data that they are never going to use. And I ask, why have you asked that question? Oh, it seemed sensible to ask it. What age are you? And I say, well, how are you going to use that data later on? Well, I don't really. Well, what's the point of asking the question? Make sure that your questions are tailored to your needs. That's another thing. So, how are you going to analyze the question? How are you going to get the information out? And remember, there is a difference between the things you need to know and things that would be nice to know. And what often is nice to know is irrelevant to you because you often don't use it. So, eliminate unnecessary questions. I have been through student questionnaires where I've eliminated unnecessary questions in the questionnaire and found that there was virtually nothing left. Because there wasn't enough thought gone into the situation in the first place. Some very common sense tips here that I can give you in terms of writing out questions are some basic rules. I don't need to pick them all out and go through them in detail, but avoid leading questions. Never ask a leading question in a questionnaire. You're not allowed to do it in a court of law. A barrister or a lawyer is not allowed to ask a leading question of their client. And you shouldn't do it in your questionnaire either, otherwise you'll get a biased answer. Would you say that? Is it fair to say that? Avoid subjective words. You often find people are using subjective terms in questionnaires. Do you exercise regularly? Oh, yes, I do that. And for one person, that means once a month, and for another person, that means once a week, another person, that's every day. But it means different things to different people because it's subjective. Avoid jargon, avoid double-barreled questions. Do you play badminton and tennis? Well, yes is the answer, which you give them the chance yes or no. And you don't know what it applies to, or one or the other. Avoid double negatives. Do you disagree that smoking in public places should not be abolished? What was that? It's like those awful little tick boxes at the end where they say, do you want your email to be used for third-party people? And you think, no, thank you very much. I don't want anyone passing my email on to anybody as a trusted, carefully selected third party. They're only carefully selected because they've paid money more than someone else has been paying money to get hold of your email. And but then they switch it around, so you don't know if it's a yes or a no. Do you tick the box? Do you not tick the box? Sometimes they switch them in between boxes. Crazy. But avoid those double negatives. Avoid bias. Because people don't like to be giving answers which they perceive to be socially unacceptable. Do you take drugs? No, I don't. No, thank you. No one does. So avoid things like that. Handling difficult or embarrassing questions. Often explain what you want there. And ensure your options are mutually exclusive. There was no point in asking how many years you worked for such and such your company, and you go 0 to 5, 5 to 10, 10 to 15. When they're choosing 5 years, which one are they going to go for? They can go for either. You don't know where they are. It's so easy to do obvious mistakes like that. Avoid them. General principles of ordering your questions. What you often don't realise is that the order in which you present your questions is very important. You need to do that. Put the most important items in the first half. Why? Because people might give up halfway through and say, oh, I've given up now. I've gone on too long, I've got to go, sorry. Don't start with awkward or embarrassing questions, because if you do, then people may say, well, actually, I don't want to answer the rest of these, and they stop even before the first question's done. Start with easy questions. Start with non-threatening questions. Start with simple yes or no questions. Go from general questions to particular questions. Go from factual to abstract. Go from closed to open if you're going to use those. And leave personal questions until last. Simple basic rules. They'll get you more information than you would if you do it the other way around. Let me ask you a test then. I've got a few test questions here. What is wrong with these questions? That one. What's wrong with that?
Have you smoked what?
Sorry?
Have you smoked what?
Have you smoked what? Yeah. It's too imprecise, isn't it?
Yeah.
You can ask a question like that. Have you? Yeah, I caught fire last week, but it's too imprecise. You cannot say it's unclear, and so many questions I find are unclear because they just haven't thought about it. What should you say? Something more precise. Have you ever smoked as much as 10 cigarettes a day for these stuff? Precise, precision here is what you are after. This another one. What's wrong with this one? Do you get out of breath when you go jogging?
Still precise. What's jogging? What's out of breath?
Well, yes, you're not precise here. It's also a double question. Because it may be that you don't go jogging, or do you go jogging? And you say no, meaning I don't go jogging. But they say, take it as a no, that I don't get out of breath when I do it. But it's a double thing as well. So the answer here is to split them up. Never have any double questions, split them up. How many apples a day did you eat when you were 8 years old?
An apple.
How many was it?
An apple.
One apple.
Wait, no.
Some questions rely upon the imperfect memory of your respondees. And you're not really testing the knowledge which they have or the truth of what they're saying. You're testing how well they remember it. Bear that in mind.
But also, in asking that question, you'll only remember the days you ate an apple.
You won't remember the days you did.
Yes, I can remember 5 days when I ate an apple when I was 8. Wow! The other 2 remember 6 days. I can't remember.
You've got a super brain.
It sums it up. It depends on memory. And you're not testing memory, maybe you're testing something else. So avoid any questions which might have an element of memory about them.
All of them.
You should probably. Okay. If you had £1 million, would you go to America for a holiday?
Obvious answer.
Why?
What's wrong with that question?
There are so many good questions. You mean £1 million?
That raises more questions than that.
If you had it.
Right.
It's what's called a hypothetical question. Okay. If you had this, if you had that, if you had the other thing. I've counted any number of hypothetical questions in surveys which are useless. And the reason why they're useless is this. Hypothetical questions often correspond very poorly with reality.
Mm-hmm.
People will say any kind of answer to a hypothetical question because they know it's way off and it may not happen. So who cares what answer I give? Yeah.
There's one that was around the university. I've been asked 2 times already about it. It's about IQ. And what IQ you reckon your parents are, and what IQ your mum and dad are, and what IQ you reckon you are. And I was like, based on what?
Yeah,
Based on what?
Based on what? Yeah.
What's the average? quite a vague question. It was
It might be more subtle than you think, that one, but I'm going to pass over it just in case.
Yeah.
Another one. When you go camping, do you sleep in a caravan or a tent? What's wrong with that question? That seems so simple. Basically,
Don't go camping.
They take for guaranteed agreement.
Well,
it presumes all kinds of things.
this is the Boolean. I would just say yes.
Yes, that's right. It's a Boolean probably, and in the words yes or no.
I do.
But there are insufficient categories here, and there are insufficient possible answers. The way to deal with that is have a category that says or somewhere else, because people may sleep in a cabin, or they may sleep out in the open air, or anything like that, or they may even not go camping at all. So allow other options that you may not have thought of. What's wrong with this one? Tell me each brand of medicine you take, the dose, and for how long since you got ill.
Too many things.
Too many things.
Yeah.
It's too many details, and people can't hold that kind of information. Break it down into a series of questions so that they become individual questions. Atomize your data, as they say in database modules. Do you exercise regularly? I've already mentioned that one to you.
I think we should be careful of the use of the word regularly versus frequently,
Yes, yes.
because regularly and frequently are a bit different. You could exercise regularly, you could exercise frequently, but not regularly.
Yes. Yes. Can you exercise regularly but not frequently?
Every 6
yeah,
months.
you could exercise once a lifetime.
They're independent. Make sure you understand the difference between word differences too. But frequently means close together, but regularly just means it happens not necessarily close together.
But to make it right, can you ask how often do you exercise?
Can you add what?
To make it right, can you ask how often do you exercise?
Yes, you can. I mean, here's probably the best way of doing it. You exercise for at least 20 minutes a day. Those kind of precision questions are required if you can do it. Enough of the common errors, and it's surprising how easy it is when you're making your own questionnaire to fall into those common errors. I can guarantee that if you just write something off the top of your head without properly reviewing it, you'll have lots of those kind of errors in it. If you want to maximise your chance of success, I've already indicated to you, if you get 5% response to say sending an email out asking for an email, you're doing well. 5%. You know, and people who send out questionnaires in the old days with stamped addressed envelopes and all that kind of thing would spend a fortune sending these out for very little return. You get even smaller return on emails. These days, one of the best ways of doing surveys is using SurveyMonkey, or there are a number of other sites which do the same kind of thing. You can put your question up on SurveyMonkey. SurveyMonkey allows, I think, free use of SurveyMonkey for about 100 responses. If you want any more than 100 responses, you pay more for that. But you can put all your questions on that, and then just send out an email giving a link to people.
And it restricts you to, I think, 20 questions.
20 questions?
Yeah, somewhere around. You can't go beyond.
Yeah, so if you've got a limited survey, it might be all right. If you want a bigger survey, then it's not all right. Some people offer incentives for responding. You've probably seen these kind of little signs which are up and down the stairwells that all the psychology students are trying to get you to take part in a survey or some test with, and they'll pay for your free lunch or give you a £10 voucher, or they'll, I don't know, give you a free haircut or something. And they'll off incentives. The only worry about incentives are that you might be biasing your sample in a certain way, and you don't want to necessarily do that. So
People who value food more than time.
well, you need people who are starving. You need to get the starving people who come along. So what I've provided here for you is a checklist of all the kinds of things you need to check through when you are constructing your questionnaire. There's a section here on an introduction to the questionnaire. Your questionnaire should have an introduction. It should have a number of items in here which explain the questionnaire. There's, for example, the guarantee of confidentiality is very important in any questionnaire that goes out. And we'll be looking in future weeks at, for example, research ethics. We'll be touching on those. And there are ethical rules, considerations with any research which impacts upon other human beings, including members of the public, which you need to take account of. One of those things is this kind of stuff: guarantees of confidentiality, guarantee that the information will not be used to people's detriment, those kind of things. brief information about it. Demographic data, you want the person's name, age, gender, those kind of things comes in, though you may not want their name if you want some kind of clear anonymity. Question format. I've got a whole set of things down here for formatting the questionnaire and the order in which they're arranged, sensitive questions at the end, all that kind of stuff. That's all in there. You can use it later on as a tool, which is why I'm providing it for you rather than going with it. There's another section here on the questions themselves, suggestions about not containing any terminology or acronyms that people don't understand because they won't be familiar with them, that they all point to the survey goals, and other things like that. Midpoint responses, a little scale, which is an odd number, is normally the normal list, but a particular reason not to use that. Closed-ended questions, open-ended questions voluntarily. So these are standard rules which are useful to you. Finally, and this is probably the most important part at this level, when you're getting to master's level, these questionnaires can be taken seriously. You have to run them properly. In undergraduate world, maybe you didn't necessarily have to do it so tightly and prescribe them so well. But in this level, you do. And one of the prerequisites of that is have a pre-test pilot. If you're going to run a questionnaire, you really should have a pilot. And by a pilot, I mean you plan to run a questionnaire with 100 people, fine. But before then, run it with 5 people, just to get some feedback on the questionnaire and watch how they fill it in and see if it's got a problem. Because all those things can be pulled up. Send it to friends or colleagues to validate the wording and the timing. Survey the questionnaire has been answered by a few survey responses from the target population as well. Make sure a few things go all right and check that everyone understands it. What's understandable to you may not be understandable to people who weren't inside your brain when you wrote the question. So give it to someone else and let them say, well, actually, I don't understand what this means. Ah, okay, let me reword that one before I send it out and do it properly. You must have pre-test pilot, check it out, see how the pilot goes. We've got a whole pile of data here on things not to do. Right, any questions on questionnaires? Make use of the tool. If you're going to use questionnaires, my final word is make use of that tool to check your questions. Make sure that every question that you're going to put down there is unambiguous, clear, doesn't use jargon, and is relevant. Has purpose and a meaning to your work.
As a recent example of a questionnaire, I was passed to many students in this university.
What's that?
And when I explained what it was, then you will see.
Go ahead.
I actually went to the site because I wanted to pass it on to my students as well.
Yeah.
And the whole questionnaire was in Chinese.
Oh, right, Chinese. Didn't understand that one then, but the Chinese expert.
We have some translators.
Okay. Now, the last section of this lecture is about sampling. I just want to explain to you a bit about sampling and what it is, and it'll be a precursor to next week's talk. Next week's talk is going to be about data analytics, and once you've gathered in your data, analysing the data. So it'll be a bit more mathematical than what we've had so far. But sampling leads a little bit towards it, and I just wanted to indicate some of the key features of sampling for you. So, first of all, the first question is, what is sampling and why do we need it? So pretty well all research gathers data from somewhere or other, somehow or other. And if you have access to every bit of data that you want, the entire amount of data is called the population. It's called here. If, for example, you're doing a survey of everybody in this country, 70 million people or something, I don't know, then you would need huge resources to contact every single person and get answers from every single one of them. That's occasionally done in this country. It's done once every 10 years. It's done under the auspices of what's called a census. And if you're looking at the entire population, which is everybody in the university or the scope, then you're not involved. It takes vast amounts of money to do that in many cases, and therefore it can't be done. It takes too long and it costs too much. So what do you do instead? You take a subset of the population and you try to make it so that subset, a smaller group, is representative of a whole. You take a sample, in other words. That sample is going to stand for the whole lot. But if you take a sample, you have to make certain safeguards to ensure that they represent adequately the whole thing. I remember a film, a very, very old film with James Stewart in it, and it was called Magic Town, I think was the name of it. And what they found was that there was one town in America which was the perfect representation of the entire country. That was a gold mine as far as market researchers were concerned, because they could just go in and ask people in that town some questions, and it would represent the entire nation. So if they asked the people in the town, how would you vote in the next coming general election? They said, we're going to vote for Republicans. Then they would know that that's what the entire nation would do. Quite an interesting concept based upon sampling and sampling methods. But because when you grab a number of people here, it doesn't always follow that they will represent everybody. You have to take some steps to make sure that the sample is representative. So there are different ways of doing sampling, different sampling methods. And there are two primary ways of doing sampling. So you can't read it very well. This one here says probability methods. And this one over here says non-probability methods. So you've got a whole bunch in blue, if you like, are the probability methods of sampling, and you've got a whole bunch in red, which are non-probability method sampling. And those two are quite distinct, and it's quite important for you to understand the distinction between the two, because almost certainly you will need to use probability sampling if you're going to do some sampling and not just leave it to your personal choice. So if you use non-probability sampling, you select the people often, or there is some other mechanism for selecting the people, or the units. But with probability sampling, the important thing is that each sample unit has an equal chance of being selected. You engineer it in that kind of way. That is the important bit. So let me give you an idea of how these things work, so that you can see which ones you may need to choose or operate with. The most obvious one and the most common one is what's called random sampling. It's a probabilistic method, and if you take a population of all these different kinds here, then you select out a number of people or units to sample here. And the important point is this is the key point. Each member of the population has an equal chance of being selected as a subject. It's not that you're going to choose all the orange ones, for example, or all the square ones, whatever. You have to have an equal number of each, so it's a representative sample. It's probabilistically the same. Each subject selected independently of the other members of the population. That's how that's done. It's done in a single step, which makes it easier to do. And often the way this is done is by a kind of lottery method. You can just choose your total thing at random. You can even put names into a hat if the sample's small enough, population small enough, just choose them at random. But you have some way of choosing them probabilistically. And all elements or members of the population have an equal chance to be chosen. That is the key factor of random sampling. That means that you're not introducing your bias into it. you're not going to just choose females, or you're not going to just choose young people. Often the problem here in a university is if you say, I'm going to choose a sample which is going to represent the entire population of the country, I'm going to go downstairs into the atrium and pick people out to do that, you'll find that there's a huge bias in favour of younger people. Where with all the old people, there are some old people around, but there's not many in comparison with the entire population. So you're not getting a randomised sample. You're biased that, yes.
That's the problem when we try to mining social media.
Yeah.
From internet, the users used to be young people, so sometimes the results can be biased.
Skewed in that particular way. And you have to show that you have dealt with that kind of inbuilt bias. Okay? Does that make sense? So, giving attention to true randomness is an important aspect of choosing your sample. It is not good enough if you want to have a general population to just choose in such a way that you will automatically bias your sample. If, for example, instead you want to say, I want to find out from university students what they think about this, then it's perfectly legitimate to go down to learn and find out at least what Bournemouth University students do. But if you want to generalise them to every university in the country, you'd have to go beyond Bournemouth University.
Isn't that making it impossible?
It does make it partly impossible. You'd have to use different techniques, maybe
Because
email techniques.
There is no real random, is there? Even if you choose in random, you are using a technique to do the randomness, and even that is not random.
That's a philosophical question. And I would leave that to the philosophers amongst us to debate the nature of whether anything is truly random. In fact, if you get this week's New Scientist, it's got a big article on it as to what randomness is all about. Personally, I think it's subjective. There we go. There's something here called stratified random sampling. I don't know if you've come across the term stratified random sampling. I've put an example of it there. This is a two-stage process. And what you have is the population, the total population here, is divided up into its individual groups, all females, all different age groups here, or whatever it may be. And you have these strata, and you think, right, there's only very few of those, so we'll only have one of them. And there's a lot of these, we'll have more of those. And by stratifying it, you have there's two ways of doing this: proportionate stratified random sampling. If it's proportionate to the population, that's one way of doing it. But you have these naturally occurring subpopulations, and you take the random samples from each strata of subpopulations. You have proportionate, so you do it in terms of the proportion of members of it. And so, for example, there's in this university, we've said there's a very large number of people between the ages of 18 to 21. That's just the way in which it is. So if you do proportionate stratified sampling here, you pick out a lot of people in that age group, quite rightly so. Disproportionate, you disregard those kind of things. Cluster sampling is another method of sampling. And this is to do with dividing the population into groups with particular traits, and then drawing a random sample from each one of them. The most common cluster that people might use, see, it's not based upon the properties necessarily of the individual, but it could be geographical, for example. A cluster in one particular area, maybe one particular town, and another cluster in another town, and you can draw comparisons that kind of way. So one example I wrote down here in the notes is if you wanted to do a survey of academic performance in high school students in Spain, then you can divide the entire population of Spain into different clusters or different cities, and then you would select a number of clusters depending on the research through systematic random sampling from those particular clusters. You wouldn't have to do it everywhere, you just pick out 3, 4, 5, 6, whatever it is, clusters to do that from the overall sample, and not everywhere. Then you've got systematic sampling. this is another way of making sure you are really random. If you take all of your population here and you number them, 1, 2, 3, 4, give them a number, or in this case I've done A, B, C, D, E. If you number all of these in such this kind of way, then you then introduce a rule which prevents you from adopting any bias. You say, having numbered them, I'm now going to take every fourth one here. So I'll count along 1, 2, 3, 4, I'll have that one. 1, 2, 3, 4, I'll have that one. Every fourth person and in my sample. And that way I know I'm going to get a kind of a random kind of approach. It's a systematic approach to the randomness. You take the order of the pool and every kth element is selected from the ordered population. That gives you a systematic approach, which you can then declare that you had no bias or input into it.
Would K being a prime number help or not? I think that's
No, it doesn't have to be a prime number at all. It could be anything, because it may be that you've got an overall population of 100 and you need to get a sample of 10. So you may say, right, every 10th one to get the right number that you need. This is now moving into non-probabilistic sampling, and this is where there is no probabilities involved in here. This is not random sampling in that kind of way. This one is called convenient sampling. It's the first of the red ones. And subjects here are chosen simply because they happen to be conveniently available. And if you just go downstairs and pick the first few people that you want to pick out or are available, it just happens to be the first lot of people who are about. That doesn't necessarily mean that they are representative of the whole group. They just happen to be convenient. So if you use this kind of sampling, you cannot claim that you have got an unbiased sample. You cannot claim that they are representative of the entire group. So if you just pick people who conveniently happen to be around, then that is not probabilistic sampling. Using student volunteers for research is typical of this kind of convenient sampling. Or subjects who are attending a clinic who are in some medical thing going on, they have to be conveniently there, but it will bias your sample because they may be ill people, and that may affect what you're trying to find out. So convenient sampling is quick, easy, a dirty method of doing it, and you have to realise that the results you're going to get may well include some kind of bias. A couple of other ones, very quickly. There is quota sampling and there is judgment sampling. And, I mean, for example, judgment sampling is one of those things where there's really solid bias built into this. But what you're doing is you're taking the experimenter and they're going to use their own personal judgment to choose people because they feel that they've got a good handle on who it is that they need to have. That shows how biasing this can become. It's based on their knowledge and their professional judgment. And this one here is quota sampling, is a non-probability method also, where you are obtaining a proportion of individuals based upon a certain quota system that you may impose upon the structure because you want so many of each. Often high street surveys, if you get stopped by people doing a survey on things, often quota samples, they want 70 men, they want 70 females. Actually, they want 90% females for this particular sampling, but it's not probabilistic at all, just what they think we want. And there's another one called snowball sampling, where if you can't find enough people, you get them to recommend other people to you, and that will enable you to get more people, but it's very, very unrepresentative of the entire group. So, all I'm really trying to suggest to you here is that you need to be very careful when you choose a sample. If you are not able to deal with the entire population, and you can only deal with a small group of them, then you run the risk of not having a representative group. Therefore, you need to take careful methodological steps to try to ensure that you have a representative group and there's no bias being introduced into your sample. For that reason, nearly always, for research purposes, you want to eliminate all non-probabilistic methods. Don't just pick up the people you happen to bump into. Don't just pick up people who you feel you judge to be appropriate. You have to have a set of tools and techniques, a set of methods or steps, if you like, a methodology, if you wish. You can adopt one from one of the ones I've shown you. You can look it up in detail to see how it really works. But you have to have a good methodological reason for choosing your sample. You have to be able to show it is unbiased. Otherwise, the results you come out with will be worthless. When you take a sample, then you are opening up your research to errors. Bear that in mind. If you are taking an entire census of the entire population, then you've got everybody. You've got everyone's views, such like what happens when people vote. You know what everyone wants, for those who do vote. But when you take merely a sample, then you are introducing the possibility of error. And there are different kinds of errors which you can have. There are sampling errors. In other words, the sample wasn't big enough. There are 70 million people in this country. I wanted to find out their views on who they're going to vote for in the elections in May. And so I stopped 10 people in the street and I asked them, how many? 10. Okay, 70 million people, 10 people you asked. Yeah, and they all tell me they're all going to vote for the Green Party. Right, okay, so what's your conclusion? So the conclusion is that the Green Party are going to get in. Right, okay, but you only spoke to 10 and the 70 million. How representative is that? Ah, well, I don't know. But, you know, there were 10 randomly chosen people. But the sample was too small. And when your sample is very small, it will affect, you get what's called a sampling error. And that will mean that there is a likelihood of error creeping in. In fact, the fact is the larger the sample, you decrease the likelihood of some types of error. So if you took 1,000 people, in fact, Gallup poll have shown that if you take just over 1,000 people, you can get a representative sample, which actually carries some meaning. In fact, those kind of polls, which you'll find lots and lots of them between now and the election in May, will all be based on a survey of about 1,000 people. And that is sufficient to show that there is a confidence of 95%, I think it is, in that. So you need to eliminate sampling errors. There are other kinds of non-sampling errors which you cannot eliminate by just improving your sampling techniques, but we have to talk about those some other time. But bear in mind there are sampling errors. Yeah.
Is there any relationship between the sampling techniques and the type of data you want to collect? For example, quantitative and quantitative. So, is there any relationships or?
Yes, there is, and I think that each of the sampling techniques is aimed at a particular kind of population, a particular kind of data, and you need to choose it carefully. I haven't really had time to go into the connections, but if you pick up a research book, and there are some I can show you. I've got one here on statistics and psychology, which is quite a useful one. They actually give you guidance on how each of those need to be used, and they go through all the steps.